Welcome back. In this task, we will learn about the basic types of data in R. The types of data that we can work with in a programming language determines the type of programs we can write. R has five basic types of data: numeric, integer, character, boolean, and factor. The factor data type is handy when we create plots or create models. We won't be doing that in this guided project series, hence we will not be discussing the factor data type. The numeric and integer data types allow us to write instructions to perform computations on numbers, for example, addition, and we saw an example of that in our earlier task. The integer data type allows us to work with whole numbers, while the numeric data type allows us to work with fractional numbers. And we use the suffix "l" to specifically tell R that we need to work with integers. The character data type allows us to work with textual data. They are also sometimes referred to as strings. Here are some examples. As you can see, we specify the character data type using quotes, and we can use either double quotes or single quotes. And we'll see some examples later. The numeric, integer, and character data types can hold several different types of values. However, the Boolean data type can hold only two values, and it is used to represent situations where we need only two values or which has only two conditions. Let's say we are writing software where we give the user a choice to either hide data or display data. If the user chooses to hide the data, we can use the value true to represent the user choice. And if the user decides to display the data, we can use the value false to represent the user choice. In the next guided project, we will see an example of this. As we saw earlier, we use variables to hold data, and we use the letters of the English alphabet to name the variables. It's actually recommended to use meaningful variable names. The variable names should represent the data that they hold. So let's look at an example. Let's say our data is the number of seconds it takes to run a 100-meter sprint, and let's say the value is 10.3 seconds. There are several different ways in which we can define a variable. Here's 8 of them. Now, if you look at the example number 5 or number 7, from the variable name, we can clearly make out the data it holds. However, the names are rather long. On the flip side, if you look at examples in 1 and 2, the variable names are really very short, but we can't make out what they mean, what kind of data they hold from the name of the variable. Examples 6 and 8 represent a good compromise. They are not very short and not very long, but we can still make out from the name of the variable the kind of data they hold. Now, the difference between 6 and 8 is in how they're specified. The way we write out 6 is called snake case. The way we write out 8 is called camel case. In R, we see snake case used more commonly, so we will use snake case in our examples. Let's practice with different data types and variable names. And for that, we'll switch to RStudio Cloud. Let me switch the display mode so you get your workspace back. This is where we left off in our previous task. Now, until now, we've been working in the console. This time, we will write instructions in a file. This is how software programs are typically written as well. So to create a file, use the File menu, select New File, and then click on R script. RStudio Cloud creates a file for us. Notice that it pushed the console down. By default, the file is named Untitled1. Let's give it a more meaningful name, and to do so, I'll click on this save icon, and it prompts us for a name. I'll type exercise.r. By convention, files that contain R code have an extension .r, and we will follow that convention. So let me save this. And now let's key in some instructions here. In the interest of saving some time, I have keyed in some instructions. These instructions create data of different data types and assign them to appropriately named variables. So the first two instructions create data of numeric data type. Now, when we were working in the console, we typed an instruction and pressed enter, and it would execute the instruction. Here, we have to explicitly tell it to execute the instruction, and we do so by clicking on run here. So we select the instruction that we want to execute, and then we click on run. So the moment I do that, notice that it gets echoed in the console, and the cursor moved to the next line. Let me do that again. When I click on run, it printed the value of LAT. Now this is a bit tedious, so this is another way we can do it. We can go to the code menu and select the run selected lines option. Notice that we can also use the control and enter keys to execute an instruction. This time around we'll select this. So when we select this, it executed this instruction, pause int assignment operator 12L. And we can see it echoed in the console as well. Now let's execute the next instruction, which is pause int. It'll print the value of the positive integer, and I'll use control enter for that. And you can see that it printed the value out in the console. The next instruction creates a negative integer, -100. And notice that we specify the suffix L when we create the integers. So that was an example of how to create an integer data type. The next two examples create data of character data type. And this example, we create character data type by specifying text in double quotes. In the next example, we create character data type by specifying the text in single quotes. Both of them are valid. Finally, we will create variables to hold Boolean data types. The first variable is assigned the true value, and the second variable, false bool, is assigned the false value. So let's execute those. If we look at the environment, we will see all the variables that we just defined. If you remember, when we were initially practicing the RStudio console, when we had typed A, it gave us an error. But when we typed A in quotes, it did not give us an error. The reason is when we typed A within quotes, it was treated as data and it was considered a valid entry. But when we typed A without quotes, it was considered a variable, and a variable was not yet defined, and that's why it gave us an error. We can repeat that exercise again. So this time I'll use x. So let's say I define x within quotes. Now if I press enter, it echoes it back because it's data, and data is a valid entry. But if I just type x and press enter, it gives us an error, object x not found, because we have not yet created a variable called x. So that's how RStudio Cloud distinguishes between a text without quotes and text with quotes. Text with quotes is considered valid data, so it doesn't complain. A text without quotes that has not yet been defined generates an error. Go on, try using the console to create different data types and share your experience in the discussion forums. Before we wrap up this task, let's look at the Files tab. Click on Files here and notice this file exercise.r. The file got saved in this cloud project directory when we created it. I encourage you to create your own files and write instructions and practice on your own. In this task, we learned about the different types of data that we can use in R. We also saw some variable naming conventions. In the next task, we will see how to write instructions using variables to perform a slightly complex calculation. So I'll see you in a short while.